It's easy. Okay, let's take it easy. Hello, hello. Okay, I'll do a bit of that. So today I'm going to talk about adjacent possible, which is really an interesting topic, interesting term. But can you tell me before we start, what does it mean?
It means that when you achieve something, some tech X, it enables a bunch of related techs like that are close to it, that are partly built by it, made of it.
Okay, so when you achieve some invention or something, it can create new inventions.
Yes.
Basically. That's a pretty good explanation. Basically, it means now we have everything we need to make this happen. And it was not possible to do this before because we didn't have this or that. And we will see a number of examples. But first, assignment 1, which is due Sunday. I forgot this morning to put down 2 extra questions for this lecture. They're really short. Basically, it's about explaining what adjacent possible means. And then I'm going to have 1 example. You have to tell me what are the enabling technologies for particular technology that is emerging, and we will see later today. Now, you have to turn it into Turnitin, and most people have signed up. If you don't have link to this, if you're not signed up, please send me an email and I will add you. Otherwise, just register, log in, and if you log in, you get a view like this, something like this, and there's New Technology 2016, and you go in there, and there you can see the assignments, and you should submit and easy to use. So put it in there, and
wait, can't you submit from your computer directly?
Yes, you can.
Oh yes, sorry.
Yes, you can. You can choose directly from your own. So PDF, upload, and we're done. So Sunday. Now, research project. Just a reminder, you should be thinking about topic, what to write about. I will give you a lot of ideas today in the second part of the lecture today, because we actually have 2 lectures today. So now is the time. Think, explore, search, develop, discuss what's going on, what's interesting, what's going on in the world, and something that is out there, not easy to recognize. Those are the best topics. And on Monday, I will have a huge list of ideas. And I think we are now in a very interesting times because there's so many new technologies that are going to change the world dramatically. And I will give you a few examples in the second. I will find a way to eliminate few jobs. Okay, let's talk about adjacent possible. This is the topic for today. So let's explore this. Last time we talked about the S-curve. Now this technical life cycle. Now improvements in products varies over time. It's really, really slow to begin with. It gets rapid, matures, and then something else takes over. We also talked about Moore's law, exponential growth. We talked about the law of accelerated returns. And this is really important. This sort of explains a lot of things. Evolution applies positive feedback that is more capable method resulting from one stage of evolutionary process to go to the next stage. So this is an insight that is very useful. As a result, the rate of progress of an evolutionary process increases exponentially over time. Like this. This is exponential. A graph made in Excel. Now, technology is also, as we will see, combinatorial. And now we are getting to this adjacent possible, how it works. Combinatorial, what does that mean? Well, ideas are built upon other ideas. So you take something that exists, you add something to it, or you take two things and add them together, you do something that will change the invention. Every generation of technology becomes a source into the next one. So it's a compaction of ideas that result somebody is building something new. This is how innovation happens. Now there's a law, and I've used this law when I'm teaching programming, Gauss's law. So really interesting law. All complex systems that work evolve from simpler systems that work. Now this may sound like a trivial thing, but if you think about it, you can't build a complex system from scratch. And if you're in the computer science department, building complex, you have to make each class, each routine, each and every component in the software, you have to make it work so it gets more complicated. Now I turn to this essay, was done many years ago, iPencil, and this guy, he argued that, we are now at a point in time where things are so complicated that no one person in the world knows how to make objects anymore like this. Or even Kevin Kelly talked about the computer mouse. Nobody knows how to make this. Well, somebody did. Well, where did it come from? Where did all the components come? To make a pencil, you have to get the graphite, you have to get the timber, you have to get the paint, the rubber eraser, which was, by the way, invented in, I think, 1858 or something. And this was used many years ago. There was a series by this libertarian guy, and he used this to explain the free market. You have to have lots and lots and lots of people do work, exchange goods, and this is how the market works. So he used it to explain. Now, if you can't make a pencil, if no one person can make a pencil, what about things like this? Smartphone. Where does it come from? How many people in the world were needed to make this work for me so I can use this? A lot. And I will give you an example of how complicated this is. So we're way beyond the time where people could make their own stuff. It takes a lot of people. Now I'm going to show you a video, and just two girls are talking about the iPhone, and it's really fake when you listen to it. 2 points. The younger one doesn't know what a smartphone is, which is not very believable. And the second one talks about the features, and one of the features is Dow Jones Industrial Average. I don't think 10-year-old girls talk about that a lot. Otherwise, it's a great video.
Smartphone. I can watch movies on it, read a book, talk to my friends on the other side of the country, face to face, download hundreds, thousands of songs, sign a petition, download programs that help me check on weather, traffic, Dow Jones Industrial Average, find out who wrote Midsummer Night's Dream, find out what they're dreaming about, translate French into English, You find the best deal with a new pair of boots.
Oh, there's a lot more to me than that. I can connect to the internet using both cellular and Wi-Fi. I have a lightning-fast 1.4 gigahertz quad-core processor, which is 500 times more powerful than the processors on the Apollo space missions. I have a 20-hour battery, 2 cameras, a high-definition LCD screen, and state-of-the-art damage-resistant glass. Yet I weigh only 4 ounces.
I want one. Make me one. You can't make you one.
Well, actually, no one can. No one person on Earth knows how to build me from scratch. Designers in California, New York, and England conceived my design. My plastic casing is made from crude oil pumped from places as diverse as Canada, Texas, and Russia. Chemists all over the world refine the oil to form raw plastic polymers. Plastics factories in China then use a process of injection molding to form my body. The copper in my circuit board comes from Chile, the United States, Australia, and elsewhere. My LCD screen is manufactured in South Korea. My image sensors in Singapore. My processor in Taiwan. The lithium in my battery is mined in South America. I am the descendant of thousands upon thousands of inventions that reach back hundreds of years. Millions of people and dozens of companies all over the world are now involved in the technologies.
Like cellular, fiber optics, internet, global positioning satellites, power generators, computer servers.
That allow me to do what I do. No one knows how to build even one of these things. Countless more people in far-flung countries play a role in getting me to a store in your city.
Like ship captains, truck drivers, electricians, managers.
Most of these people are seeking simply to meet their own needs and achieve their own purposes, and have no idea that they play a role in my creation. Of course, I'm not the only smartphone. Different businesses compete for smartphone customers. These competitors inspire my company to make me more fabulous, while still pricing me so that millions can afford to use me at work and at play. Competition also means that my technology, as cutting edge as it is, will be obsolete by your next birthday. If I didn't already exist, you might think that such a flowering of free cooperation, competition, and creation was either impossible or magical. And yet, here I am.
Wow! Tell me again.
Okay, so it's a good lesson in understanding how capitalism works. But the ideas of cellular phone, somebody came up with this in the 1940s. Engineers at Bell Lab, they created a blueprint of how cellular network would work. So you had these cellular towers and you had radios. But it was only until 1987 something that people could make the first mobile telephones. And they were really clunky. And the first Nokia phones, they had battery cases. So in 2007, we saw the iPhone, which is very much used as an example here, because it's a great example. Now, why did it come 2007? Why did it come 2007?
Because computers have improved enough to make it practical to shrink them into a phone and yet still be affordable.
Exactly. Computers had shrunk enough, so they were small enough, powerful enough to be created in a case like this. But also, all these sensors, GPS, all that stuff were so small that you can put this together. The screen technology was there, everything was in there at this moment. So they created this. Now, to continue with this point, let's say you wanted to build a toaster. And I mean, we have Wikipedia, we could look it up. We could go to the store and reverse engineer a toaster and try to build it from scratch, from Earth. And this is exactly what this guy did. He went out, called it the Toaster Project. So he wanted to create a toaster. And he gave a TED talk. You can go on the toasterproject.com or .org or whatever. and he documented the journey. So he wanted to create a toaster, and this came from a Douglas Adams novel. So there was this guy on a planet, came from Earth, and he went to this planet where all these primitive people are, and he had, all the knowledge from Earth, and he wanted to show these primitive people how to build a toaster. Let's watch the video.
If we look around us, much of what surrounds us kind of started life as various rocks and sludge buried in the ground in various places in the world. But of course, they don't look like rocks and sludge now. They look like, TV cameras, monitors, annoying radio mics. And so this kind of magical transformation is what I was trying to get at with my project, which became known as the Toaster Project. And it was also inspired by this quote from Douglas Adams. And the situation is from The Hitchhiker's Guide to the Galaxy. And the situation it describes is the hero of the book, he's a 20th century man, finds himself alone on a strange planet, populated only by technologically primitive people. And he kind of assumes that, yes, he'll become these villagers, he'll become their emperor, with transform their society with his wonderful command of technology and science and the elements. But of course, realizes that without the rest of human society, he can barely make a sandwich, let alone a toaster. But he didn't have Wikipedia, so I thought, okay, I'll try and make an electric toaster from scratch. And working on the idea that the cheapest electric toaster would also be the simplest reverse engineer, I went and bought the cheapest toaster I could find, took it home, and was kind of dismayed to discover that inside this object, which I bought for just £3.94, there were 400 different bits made out of 100 plus different materials. I didn't have the rest of my life to do this project. I had, maybe 9 months. So I thought, okay, I'll start with 5. And these were steel, mica, plastic, copper, and nickel. So starting with steel, how do you make steel? So I went and knocked on the door of the Rio Tinto Chair of Advanced Mineral Extraction at the Royal School of Mines and said, how do you make steel? And Professor Silius was very kind and talked me through it, and my vague rememberings from GCSE science, well, steel comes from iron. So I phoned up an iron mine and said, hi, I'm trying to make a toaster, can I come up and get some iron? Unfortunately, when I got there, it emerges Ray, he had misheard me and thought I was coming up because I was trying to make a poster, and so wasn't kind of prepared to take me into the mines. But after some nagging, I got him to do that.
It was crease limestone, and that was produced by sea creatures 350 million years ago in a nice warm sunny atmosphere. When you study geology, you can see what's happened in the past in the world, terrific changes in the earth.
But anyway, I got my suitcase of iron ore and dragged it back to London on the train, and then was faced with the problem, okay, how do you make this rock into components for a toaster? So I went back to Professor Silius and he said, go to the library. So I did, and was looking through the undergraduate textbooks on metallurgy, completely useless for what I was trying to do, because of course they don't actually tell you how to do it if you want to do it yourself, and you don't have like a smelting plant. So I ended up going to the History of Science library and looking at this book. This is the first textbook on metallurgy written in the West, at least. And there you can see that woodcut is basically what I ended up doing. But instead of a bellows, I had a leaf blower. And that's something that reoccurred throughout the project was, the smaller the scale you want to work on, the further back in time you have to go. And so this is, after a day and then about half a night kind of smelting this iron, I dragged out this stuff and it wasn't iron. But luckily, I found a patent online for industrial furnaces that use microwaves, and 30 minutes at full power, and I was able to finish off the process. So there's a picture of my toaster. That's it without the case on, and there it is on the shelves. Thanks.
Okay, so the lesson here is that, getting to an iron mine and smelting iron is not easy, but somebody does this. So this is consolidated to a very few companies that supply the world with these basic materials. And making things from scratch is, well, definitely not easy. But there was so this is the quote. He could just about make a sandwich. This is the end product and all the things inside it. So even a toaster, a stupid toaster, is a complicated thing made by a lot of people that come and have to work on pieces of this. Now, this quote is something he said, and that was something that reoccurred throughout the project. Was the smaller the scale you want to work on, the further back in time you have to go. So he did not go to the library, he went to the history library, history of sciences library. Now, why was that? Because the textbooks, modern textbooks, don't teach you how to smelt iron. Nobody wants to know that because it's technology that is gone. It's in layers, and somebody knows how to do it. It's an instructional manual. Maybe Rio Tinto or some company is doing this. So it's in their instruction manuals. They know how to do it. But nobody else needs this. You just, if you want steel or iron or aluminum, you just buy it from some store. So this brings us to these layers of technology. Technology evolves layer by layer from simple to complex technologies. It's a combinatorial process. So new technology is created by combining other existing technologies in new ways. And this brings me to a law that I came up with. It's the law of disappearing technology. When some technique is faster, it will disappear. As something obvious and trivial and other more useful things that are built on top of it will emerge. So think about, there are a lot of examples. When technologies are new, we consider them a technology. But when they are old and established, everybody assumes they exist. We take them for granted, they disappear. They still exist. They are not considered technology. So it means that when it becomes useful, it disappears. For example, electricity. We don't think electricity is some form of technology. It's just there. You just turn on the switch, you have light. Or you plug something in, you have power. It's disappeared. And the same thing with the internet. It's disappearing. It's going away. And every time something goes away, it becomes really useful. And there are more examples. Computers. Computers were technology once. Really difficult. You had to go on a 2-week course just to operate the damn thing. Now there's a corollary for this. Even outdated things that we really need to get rid of. It doesn't want to go away. Let me give you a few examples. Phone books. Do you have more examples? Technology that is useless today. We don't need it, but still it is used by a lot of people.
Fax.
Anything else? That's an obvious thing. Good choice.
I hate that bloody machine.
I have a fax. It's an app. You just take a picture, and it will turn it into a fax-like document. So it looks like fax, and then you send it. Nobody knows the difference.
Yeah, I've had to fax 6 months of financial records for a company I used to work at.
Yeah, okay.
That was not a fun week.
Back in the 80s, I used to work for a company, and the boss, I worked for a different company, and I was doing work for him. And he would send me instructions on fax. He would just, I would get a fax, really big letters. You need to do this. Okay. So he communicated that way. I mean, it's almost as bad as email, but I don't know. Landline phones, you know, I tried to get rid of my landline phone, but the guy said, you know, then you can't have the TV. What's that? Printed newspapers? They're still bringing this to my house. And I take them every week. I take a chunk of newspapers and put them in the blue garbage can. And I should put a note, you know, just put it in the blue. But then they get so full very fast. So keys. Why do we have keys? This is starting principle. Plastic cards. You shouldn't even have a wallet. All you need is a phone. You can have your cards here. You can have your keys here. When you get home, the doorknob should realize you're home, and it should open. Or when somebody comes, you want to let them in, you can do it from work. I mean, we have the technology, we have the internet, we have all these things. Now, close to my business, I'm not going to say a word. But let's continue. Let's explain what this means. So, kind of a shadow future hovering on the edge of the present state of things, a map of all the ways in which it can represent itself. Remember when I talked about the room? So you have all the knowledge in the world in this room. And then you take that and you get a new idea. And then a new room is opened. A door opens and you get into a new room. And that has everything plus the new idea. And so this goes on. So everything in the world we can use to invent something else. Now it also means that if you have a really revolutionary idea and the room that you want to get into is far away, there is no door, you can't get there. You can't get there because you need all the enabling technologies to get there. So this continues exponentially. And this means that usually a lot of people have the same ideas. Let's take an example. In 1820 or so, 30, and then up to 40, people were figuring out how this electricity worked. And by 1840, 50, they had sort of figured it out. They knew how to work electricity. And then the question is, who invented the telephone? You should know this. Well, yes.
Credited, at least, I think.
Well, he is the guy who invented the telephone, Alexander Graham Bell. Was he the only one?
No, there was someone who was just like days after, if I remember correctly.
Or the same day, Elisha Gray. There were a few others. With Meucci, 1854. He did a lot of experiments for many years. And he truly invented the telephone before Bell, but or that's what they say, but he didn't commercialize it. He didn't take them. Philip Rees, John Philip Rees, he invented, I read somewhere that he invented the first telephone that didn't work. Very useful device. But then Bell came, Elisha Gray, he was working on this device, and they actually filed a patent with the Office of Registration, whatever it's called, the same day. The same day. And there was a huge dispute over this, and for years they were in court. And then other people like Edison was improving on this. So a lot of people were working on this at this time because all the enabling technologies were ready. Bell got a patent, so he owned the invention. And for 17 years, he had the rights to telephone. Nobody else could sell telephones. So existing technologies that can be used to build new technology. And then we can wonder, why was the computer invented in the 1940s and not the 1980s? 1840, sorry. It was invented in 1940 something, during the wartime, 39 plus. But this guy, you know this story, at least the computer science students. So Charles Babbage, he worked on his difference engine and then later the analytic engine from 1822 to 1871. And even Ada Lovelace, 10th of December is Ada Lovelace Day. And last December, 200 years old. Just want to point that out. So she even created the concept of programmable computer, the programming language. So all the ideas were there, but it didn't happen. Now the question is, why couldn't Charles Babbage create a computer that worked? He didn't do it. They built one later.
They didn't have the enabling technology.
Yes, they didn't have the enabling technology. They didn't have the nuts and bolts and cranks and clutches and all the workmanship at the time wasn't good enough. They couldn't engineer it. You couldn't just go out to the store and buy this. You had to build these from scratch. And it was difficult, really, really expensive. And even if the idea was there, you couldn't build it. And later, somebody, I think it was Paul Allen or somebody, he commissioned a work to be built. And they built it, and it was in, if you go to London Science Museum, you can see some of these machines. It's actually a really, really nice museum. So when all the enabling technologies are ready, then new invention will come. But these were mechanical computers, and the first calculators were mechanical calculators. Of course, when people realized you could use relay switches, vacuum tubes, and stuff like that, then it was possible to build electronic computers, which were called, ironically, electronic brains. We will talk about electronic brains. The inventor must use the component that exists in his environment. Now, I was going to show a video from Apollo 13, I think it is. But if I do that, YouTube will take down my video because you have to sign an agreement with makers of this movie, so be careful. But when vacuum tubes were available, people could finally build those things. And if you think about it, there was this, people are talking about the fourth industrial revolution today. We know about the first one. This is the second one. I'm not sure what the third is. So from 1870 to 1914 until the war, that was a boom time because we had, chemical, electricity, petroleum, steel. People had figured these things out. Now with those, they could build a lot of things. So it was a boom period when people were taking these inventions and using them. And I feel that today, 2016, we are in a similar place where we have all the enabling technologies, wireless, computer chips, all that stuff. And this is why we will see things like Internet of Things and a lot of stuff. So things happen in long waves. Then we will take, for example, steel industry, it will boom for years. Then railways came, it will boom for years. And then it will sort of decline. And this means that there are sort of waves. And this guy, Russian guy, Kontratiev, he came up with these long cycles. So his observation was that, and he named them after himself, of course. So you have these periods, and this goes for decades. And you can see we are in the information technology that has lasted from 1980 or something like this. So these become the dominant technology over them. So sort of waves. So when one wave is about to end and another wave is about to start, funny things are happening. And take a look at this. Now, this is a car, an old car. And they have two drivers, probably one to drive. The other one is probably a mechanic to fix the car you know, when they had driven 200 meters and breaks down. Or it might be the guy. Usually they had three, because there was one guy with a flag, you know, and he would walk in front, you know, warn all the, and if there was an animal, they had to just get out of the way, like horses. Now, what is strange about this picture? There's one thing that I find really interesting. Cars are not like this today, obviously. Any guess? Very good. It's like a horse carriage. It's like stagecoach. You see the wheels, the position of the driver. Smaller in front. They're high up, so they can see. But there are no horses. You don't need to sit that high. The reason why people sat up high was to see above the horse. Otherwise, you would just be looking at the horse's ass. So this is what I call the prevailing technology trap. Because you're used to this, and you try to cram new ideas into new platforms when they come. So because we're so focused on current and dominant technologies, they will influence anything new. And let me give you two examples. So you probably read Winnie the book. Beautiful stories. And Wired magazine, you probably seen those things. At least you know what a book is, and you know what a magazine is. So then Steve Jobs and Apple, they come up with the iPad. Now what can you do with an iPad? Well, you can read books and magazines. Perfect. And how do we do that? Well, you have a bookshelf, and you turn the pages. So the trap again. Now you have this device. Why do you need to have it look like a book and have pages? Well, maybe the argument would be, we need to get people used to reading books on this. Books is just a string of text, very long. The reason why we have pages is because that was the technology that was before. But Wired actually did it differently. Now think about a magazine. You turn the pages, and there are some stories in a sequence, but they did it like this. So you see, they use the medium. But the first step is always take what exists and try to cram it into whatever we have. So that means we always have two waves of product development. First one is trapped into the old ideas, and the other one will escape it. And there's something new. So a lot of examples. When the first Microsoft Windows application came to the market, ironically, they looked like DOS. People were using the same metaphors, not using Windows as it should be, because they were trapped in the thinking of making DOS programs. The web, Amazon, it's like a brochure, a page. And then you go to this revolution like in 2004, people started to talk about Web 2.0. I don't know if we are in 3.0 or 5.0 or whatever we are in, but people started to use this interactively with lots more pictures. Of course, the bandwidth was not available with Amazon, but the first web pages, they were really simple pages like a journal or something. And then people started to escape this form and create something truly new. And also, Britannica went online. Yeah, our glory days will be back. And then these guys said, why do we need to write this stuff? Why don't we create a platform and allow people to write this stuff? And there are lots of people there are actually a lot of people that write on Wikipedia. A lot of people that write really very small things, but few people that write a lot. So now we have this medium. It's meant to many. We don't have to have broadcast where we write everything. So each wave creates a number of new inventions. So when the time is right, new ideas emerge. Okay, let's take a break, a little early, and when you come back, we're going to play games. Okay? Ja, precies. Stăm să mă apuc de fac. Okay. Þetta komin á sunnudag. Nei, næsta. Þennan sunnudag, síðustu sunnudag. Þannig að það koma á það. Já, þú þurftur að horfa á fyrirlesturinn, sko. Það var hérna tvers, það byrði skotið á mig. Það skilur því núna á sunnudag. Já. Það verður sko eftir hvert fyrirlestur við komum. Það var spurning. Fyrirlestur. Og núna komið spurningina núna strax eftir þessum. Það er mjög lítið tími fyrir síðustu fyrirlestur. Það er mikið tími fyrir fyrst. Og fjögur svona sex bara yfir. Það eru hugsað sem litla æfingar þannig að menn hugsa. Já, hugsaði saman. Sér eitthvað. niðurstöðuna sjálf. Þegar við erum að loka það. Og svo eru þau Nei, tilvalið loka þenni. Finnum við bara þannig. En það sem við ætlum að tala síðan seinna, það farið í gegnum það. Já, ég kann það. Ég kann það segja nær dreg, þá er að tala þetta. Fyrst og fremst geta heimilda, finna heimildir, geta heimilda. Og síðan hvernig á byggt sér svona. Það er ákveðin svona, akademíski pakkurar, þeir hafa ákveðina reglur, sem er strikt reglur. Það er ákveðin svona abstrakt og kemur ákveðin svona flæði. Við erum til dæmis í akademískum pappir að telja allt sem búið er að gera á þessu sviði. Svo kemur þú með eitthvað nýtt og síðan takkur máttu ekki fullið að neitt. Ekki neitt. Þegar maður er sannanlegt. Ef þú segir já, fullt af fólki finnst þetta skemmtilegt. Hvar hefur þú sönnum fyrir? Gerður þú survey, skrifur? Og ef þú gerir survey, þá verður að segja svona margir konur, svona kallar, þetta er aldurinn og þetta er svæðið. Eða þetta var ófamlegt við til í tunglunum, og þá segir þetta er helmingurinn að það skilur þannig að það verður alltaf þannig að ég tala bara þetta setna þegar hann nær dregur að hann bara gerir það. Okay, let's continue. So I want to play a game, but I forgot the game itself. You know, you can go to these stores and buy these games. It's a small little game called Timeline. Have you seen that?
Yeah.
Have you played it?
No.
So it's a game where you have a bunch of cards, and on one side there's a picture of something. Could be a picture of a PC, and then it says personal computer. On the back side, there's a date when the PC was invented. 1970. What did you say? 77? 5? I can't remember. And the idea is that you're playing with a bunch of people, and you have like 4 to 6 cards, depending on how many are playing. 4 to 6 cards. So you have like, let's say you have 6 cards, and then you take one card and place it on a timeline. And now it's your turn. And you can take any of your cards, and all you have to do is it before or after? Yeah. And if you fail, you'll have to draw a new card. And this is interesting in the beginning, but then it gets really, really hard because the space is between dates. As more cards come to the table, to timeline, it gets more difficult. And it turns out that having dates on when things were invented is really difficult. So when was so I'm gonna have you play. So I'm gonna somewhere here split the room. There are 2 teams. This side is in one team, and this side is in one team. So you are a green team, and this is a red team, okay? And you guys in the middle, you can sort of decide. Most people are in the green team probably because it's quicker to go. You know, I started to sit by the exit, so I can leave. So I'm going to put one card down, and we're going to do this in this order because, you know, the presentation program that I have doesn't allow me to select any card. So I'm going to place a card. So this is timeline, minus 10,000 until today. I don't know what scale this is. So I put this card down. So I did this randomly. So I draw 6 cards, then another 6 cards, and then a card to put on the timeline. So the slide rule is 1624, according to the game. Now, green team. Let's take the brick and put that on the timeline. It should be an easy one. Was the brick invented before the slide rule or after the slide rule? Before. You sure? Before? Of course it's before. So it's somewhere here, minus 7,000. So that's a really, really old technology. And when you have brick, you can build houses. So it's an enabling technology for a house. Okay, telescope, red team, telescope. Give me a date. Or let's start easy. Is it before or after? Before.
Before slide rule. Yeah, I could believe that.
1500s.
Okay. What is that? Before.
Early 1600s, something like that.
So minus point. Okay, rubber eraser. Did I mention this earlier? I got it wrong. Sorry.
Something like 1876.
Anybody else?
The eraser comes after the telescope.
After the telescope. Okay. I said 18 something. Whoa, I was wrong. 1770. Rubber eraser. Okay, then the red team, violin.
Early 1600s, I'd say.
Before the
slide rule.
Before the slide rule. You agree? 1548. Somebody invented a violin. Okay, navigation. The question here, it's probably older than, grid or violin, but, where is it on the line?
Navigation does predate the violin, but it comes after the break.
Do you agree?
No. I think people would have figured out, the polar star and stuff like that really early.
Earlier than the brick then. At least earlier than the violin, you're saying. Well, it's actually like 4,000. You didn't go anywhere. Probably. I don't know. So, okay, the typewriter. Now it's get difficult. Typewriter. Who invented the typewriter? Do you know?
Typewriter.
I don't know who invented the typewriter. Must be a writer, probably. A journalist. So, typewriter, is it, where would you put it? Between what?
Really late, like 1800s.
1800 something? Let's put that down. 1873. Okay, really, really useful invention. Cork. Now, it was invented way later than people invented bottles. So, they had to use something, I don't know what. Cork. But do you know the corkscrew was actually invented much later? So people had to chop off the cork. Where did you put the cork? After the violin. Oh, before the violin. It's difficult. Let's put it down. 1695. Okay, barbed wire. Very useful technology when you need to have cattle, so they don't go away. But when was it invented? People had cattle since way back. But when did they invent barbed wire? Anybody?
I have a feeling that it was originally invented for war or something like that. So
For
later
war?
than you think.
And where would you place it? After the typewriter? Before the typewriter? Before? The year after the typewriter. Somebody invented. Okay, submarine.
After the erasers.
After the eraser. Okay, let's say that. What? Are you googling this?
No, I just read remembered one article I read way back about the first submarine.
Yeah. Okay. I mean, it would be cool to have a quiz like this and have everybody in the room with phones cheating. It would be interesting. Hourglass. Where would you put that? Hourglass. Before the violin. Perfect. 900. The safe.
After the violin and the hourglass.
Between.
Maybe after the cork.
Let's put it down. It's actually 1844, so it's not that old. And the last one, ceramics.
That was, didn't Chinese have ceramics like insanely early?
I don't know.
Like pre-navigation early.
Let's put it down. Right. So it is not easy. It is not easy. But it's a great game. You should check it out. Okay. Okay, so what I want to talk about next is how innovation happens. But we're not done. Now we have a second lecture. So what I try to do in the early lectures of this course is to reflect a little bit, see what happened in last year, what is happening now. So I have some technologies that are really interesting at this point in time. But I usually start asking, what happened in what was the major technological breakthrough in 2015? Anybody? What great invention was invented, and everybody talked about it for a long time?
There was much talk about VR, but I don't think that would.
VR, I would put, it's a good guess, I would put VR, this was a year of VR, definitely. A lot of talk about VR. But not the average people. Technology people, yes. But not people, normal people that are not looking at technology all the time.
Tesla Model S.
Tesla did great stuff. But I have one thing that, if we look back at the year, there was one date that was really interesting. And it was this one. This happens to be my birthday, actually. So this is today.
Little girl, stop. Look, I need for you. Where is he?
Remember this?
He's off the course.
So the question is, where's the stupid hoverboard? There was a research paper that was written last year about the technology in Back to the Future. And it was categorized what they got right, what they got wrong, and sort of extra things, like the fax machine, way wrong. They got a lot of things right. Not the hoverboard yet. The fax machine was one thing, but there was one thing that was totally missing, and that was smartphones. Nobody in that movie had a smartphone. So they missed that. They didn't see that. But we did get something from that movie, and that was almost like the whole movie. So this was the technology of the year. And it was very popular at CES show, not this year, but last year. But then it was horribly expensive, and nobody bought it. And now people are making this cheaper, so people can buy it. Have you tried this? It actually works. Yeah. That's fun. That's funny too. Well, you can actually go to a store and buy this here.
What makes this different from the Segway?
It's smaller, probably. Segway has a wheel.
Yeah, but I mean, you wouldn't call a smaller car compared to another car. You wouldn't call that a hover car.
No, I would call it the same. It's smaller.
It's just a small Segway that doesn't have a handlebar.
Yeah.
That's basically the experience.
But why did the Segway have? Why is the Segway so big? Probably because of the technology. I haven't looked into it, but now they can make it smaller. That's my guess. But there was also one thing that happened, and of course that was, as usual, people waiting in lines.
So that's why we have a nice line of people at this Maxfield where you can purchase the watch today.
The Apple Watch. Now the guy that was sitting there in front, the reporter would stay there all night, talk to these people, and they'd stayed there for a couple of for I don't know many hours, And he asked him, what type of watch are you gonna get? Oh, I'm not getting it for myself. So he was paid $200 to sit there for 12 hours to wait for this stupid watch.
That's $100 an hour. That's pretty nice deal.
Well, so fanboys again. Now I'm going to show you a clip here. The question people ask: why would you need a watch? I actually like mine. Doesn't do much. Tells the time. That's very useful. Tells the temperature also, so I can see how warm it is outside. Tells the next meeting. I think we are in the beginning of something that is going to be really useful. When this thing will direct your life, tell you what to do next, and put it into context. Because you are located here, so you must be doing this. And then it will tell you something. That's predictive intelligence.
Shut up! Yeah, it's 12:15.
It took 1.5 seconds for you to check the time.
Time that.
With the stopwatch on my all-new Apple Watch, just one of the amazing features it has.
Doesn't the iPhone already have a stopwatch? Yeah, who the hell wears a wristwatch anymore?
The better question is who doesn't?
Newborn babies, someone with 2 broken wrists, a guy with no arms, people with really small block phobias. Pretty much everyone, really. Why are you even so excited about this thing? Yeah, it's just another useless Apple product they want us to think we need.
It's a really sexy watch. Too bad you guys don't have a career with that ugly wrist.
Okay, we got your stupid watch now. What can it do?
You can tap on it and your friends will feel the tapping.
That is really creepy. Is Apple trying to bring back Morse code or something?
It can send a heartbeat
Why would you want to do that?
so you know your friends are still alive.
Yeah, why wouldn't my friend just send me a text or call me? Yeah, or they can send you a picture of them not dead. I gotta go pee.
Oh, it's just a quick tickle. Why don't you fellas stay there?
Our plan didn't work, but you fat-shamed their wrists into getting the watches, right?
Yeah, and they still think they're lame.
They won't after you let them know you can run home appliances with them.
Only the internet needs ones, like your TV and your TV.
Why would I want to turn my TV on while I'm not at home? Yeah, that's almost as pointless as sucking a fat man's nipples for milk.
I'll be back.
What kind of a metaphor is that? Okay, it's not a metaphor, it's a simile, and I may have tried it once. I don't recommend it.
This goes on, and it gets even worse. And I will put the link to this. And they actually find one use case for the watch, and you have to find out yourself. Okay, I did something yesterday. I created a song. I'm gonna play it to you. So it's a song, rock kind of type, uplifting, cheery kind of song. Let's listen. I'm in. Seconds. Would be perfect to have like 15 seconds before the recordings of the lectures. But I did this. I did everything myself, except I don't know nothing about music. I actually studied classical music history when I was studying abroad, and that was the best part. You could come to lectures and listen to other people play. Fine. But I did this. It took me like 2 minutes to get the file, MP3 file ready and everything. So I went to this site called Duke Deck, and I selected to have rock uplifting 30 seconds. And then I created a track, and I got the track. Soulful mix. That's how I did it. These guys have a computer program that lets you write songs. So it's composing. Listen to this again. This is a computer that did this. Is this a bad news for composers? I don't know. They use machine intelligence. So if you are looking for topics for research paper, that's the term. Machine learning, machine intelligence, deep learning. I think the next, and this is a quote from Kevin Kelly, who we met before, the next 10,000 startups is going to be something machine intelligence. And this is why we need machine intelligence in this thing here. It's going to be everywhere. And I will show you later how this works. But you can go to Amazon and use their deep learning recurrent neural network. So this actually is an old idea. Have computers learn, not program, but they will learn. You create a program that learns. And then you can throw, oh, this is chess. Now play chess, and we go and play chess, or whatever. Understanding speech, understanding language, doing things that are really, really hard. Now this goes way back, way back. And we've been waiting. This is in the 60s. Ironically, people talked about electronic brains when these were just oversized calculating machines. They could do nothing that is intelligent. Now, if you take a picture and ask a 2-year-old to tell you where the cat is, it will be very easy. They will point to the cat. Try to build a computer program that can do this. And a few years ago, Google did. They created a brain simulator that teaches itself to recognize cats. Now, why would they do this for a cat? Because what's on YouTube? What is the single most popular category of anything on YouTube? Cats. If you're searching on Google and there's cats somewhere, you can't find nothing but cats. So a neural network of 16,000 computers that you lose on YouTube images for 3 days, and what did it learn? How to recognize cats. This is a huge breakthrough. People make fun of this. For example, this, Google creates computer brain and immediately starts watching cats on YouTube. like that was one of us cats. But think about what that means. You can take images and find out what's in the image. Bodies, people, faces, houses, cars, whatever. This is a really, really difficult problem. Now, what we will do later, we will talk about machine intelligence, but briefly what they do is they create neural networks. Now, the idea of neural network is way old. It goes way, way, way back. In the 80s, there was a lot of talk about neural networks. It was sort of one of these booms in AI. AI, for the first time, is actually doing something that is really useful. It has done a lot of useful things, but it has been, hope and then winters, people abandon things because it's a field of total ridicule. Do you have a question? Comment?
Elon Musk and more people told that we have to be careful with.
Oh yeah, Bill Gates, Stephen Hawking, yeah. We have to be careful with this. I really understand why. This is really scary. Now, I did research this summer, and whoa, this is scary. Okay, let me show you one video that is explaining this, and I will later show you more of this.
Hi, I'm Nat. And I'm Lem, and this is our 20% project, where we go find out about different Google stuff we're curious about. Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning. Since then, we've been kind of fascinated by it. So today we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well,
There's a lot of problems that's really easy to solve with computers. Computers can go and like simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem, like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it. But for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters. When you go to the ATM and you give a check and it can read the handwriting. Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos, here are all my dog photos, here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn. But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a tractor, things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal. It's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that are tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog. And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything you can classify as? And suddenly you can go and ask, neural net, what do you think cat looks like? You get a picture of a cat, or neural net, what do you think a barbell looks like? These weights. And it goes and shows you a picture not only of a barbell, but an arm attached to a barbell. So the model thought that the arms, if it only learns what barbells were from looking at pictures of barbells, they're often held by muscular weightlifters. And so it learned that there was, barbells and arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, say to a kid, that's a filing cabinet. And then a second later you say, what's that? He's not going to be able to, shoe, right? You know,
Like, the more you describe this, the more I'm amazed by human beings.
yeah.
Like,
yeah.
the effect is like, wow, human being really amazing.
We're really amazing learning machines.
So you know, fix the spam. That's one thing. I actually read on the news that they had Google had mapped all the numbers in France, house numbers. I read that. Okay, so this is really, really scary technology, and I know why. People, if you look at this, this can do programs. This can do a lot of things. Cannot do art, or can it?
Yeah.
Well, these are paintings. There's a site called deepart.io. You take a picture, for example, a picture of yourself, you select a style, and then you get a new picture. I did this. So here's a picture of me, this is the style, and I look like this. And if I took the picture of Reykjavik University and told this machine to paint it like Vincent van Gogh would paint it, and came up with this beautiful piece of art. So that's one thing. And think about this. What were the enabling technologies for this? Why is this now? Think about it. Another thing that I want to mention before we leave is Internet of Everything. This is really, really interesting because we have all the enabling layers ready.
Ubiquitous computing.
Sorry?
Ubiquitous computing.
Well, that's one way of describing it.
Becoming responsive. Intelligent sensors can anticipate our needs. The Internet of Things is a game changer for the Port of Hamburg, with a goods turnover of 140 million tons each year. Numbers are expected to double by 2030, a serious challenge for the Hamburg Port Authority. Located right in the heart of the city, with limited space for expansion. To grow, the turnover of containers needs to be faster. The port has to ensure that trucks, ships, and containers are only in the harbor area when they are really needed. The Internet of Things brings the solution. Every component in the harbor is communicating with each other. Ships, trucks, people, cranes, bridges, and traffic control systems. Everything is providing data to give insight to the business. Trucks reach their destinations faster. Drivers know where to unload more quickly. Shippers can plan their tours proficiently and react to new challenges in real time. As a result, the port can handle more goods faster, simpler, and impact businesses way beyond harbor premises.
So it's propaganda from SAP, but it's really a great example. How do you improve efficiency of a harbor? People are talking about smart harbors now, smart ports. Well, you have it in real-time software, and then to do really amazing things. Next one, 3D printing. Do you have 3D printers? No? I started talking about 3D printing many, many years ago in this class. And people shook their head. What is this guy talking about? You can print stuff. Today, it's easier to talk about these things because people have seen them. But let's take a little bit of it.
3D printing is a technology that lets you take a digital file and turn it into a physical product.
Almost anything you can imagine, people are creating. I think it's going to open up whole new opportunities in areas of mass customization.
Unlike with music or movies, with a 3D printer, a lot of things that are printed are protected by copyright.
One of the really cool things about 3D printing is it really changes the dynamic of the consumer culture. It turns you from being a passive consumer to an active creator. 3D printing is this amazing new technology where you can take a 3D digital file and with a click of a button, use that file to create an actual physical 3D part. So how does a 3D printer work? The first step is to get a 3D file, and you can get your 3D file in one of two ways. One, you can simply download the file from the internet. The second way is you can design your own 3D part. The software is going to slice your part up into layers. By building a part layer by layer, you're able to create a plastic part in 3 dimensions, and the possibilities are limited only by your imagination. People will create their next big invention, or engineers and designers create small production runs or little prototypes. Teachers can use it to print out teaching aids. If the teacher is doing a little lesson on a ship, they can actually print out a sailing ship and pass it around the class, and people print out things for around the house. iPhone cases are pretty big. You break a towel hook, you can print out a new one. We want to make 3D printers at a price that the average person can afford and also easy to use. We're already seeing late stage early adoption of 3D printing, but for me, the exciting thing is what's to come.
Shapeways is an online 3D printing community and marketplace. Anyone in the world can upload their 3D model and we'll print it for you. And then also, if you decide you want to make it for sale, you can sell it and we'll produce it on demand for that customer wherever they are in the world. You can essentially bring a product to market with no risk. You don't have inventory anymore. You don't have to make sure that there's a market ready for your product. If you sell 1, that's awesome. If you sell 10,000, then all of a sudden you have a passive income model, and that radically changes the economy. Usually to bring a product to market takes a year, and then you have to find the manufacturer and the investor. And so it's going to force us to change the way we think about not only buying products, but how they're made. One of our colleagues broke his stroller and it would have cost him something like $250 to get that part in the mail from the stroller company. And he literally just 3D printed a stroller part and got it for $20. You have this explosive technology where everything is made just for you, but at the price and quality of something you buy in the store. This could be a scary technology for some companies, because what does that mean for seasons now? You have infinite inventory, and what does it mean for scarcity, which is one of the core tenets of so many industries? I think it's very similar though to social media or other tools of engagement where you're afraid to see what that would mean to let consumers co-create with you, or to really rethink your traditional manufacturing process because you have so many middlemen. I think we just have to stop thinking that you need to reach 100,000, 1 million people for something to be successful. Customization is really changing the way that we have to think about design and production as well.
3D printing is going to have a profound impact on all of us, whether you consider yourself a designer or not. In the future, there are going to be 3D printers that will allow you to actually create 3-dimensional structures out of living cells. And they can build very complex structures like blood vessels or skin tissue. And the idea there is that in 10 or 20 years, these scientists are going to be able to 3D print tissue that can replace damaged vessels in the heart, or they're going to be able to print replacement materials. So you won't have to go to find an organ donor anymore. You just have to have one 3D printed at the hospital based on your own cell, your own genetic makeup. Right now at MIT, scientists are working on 3D printers that actually allow you to print food. And who wouldn't want that next, right? You can just ask Siri to cook you a steak. It's really going to be an exciting time. In Japan, there's a company that's taking a sonogram demo. So they scan a pregnant woman's belly, and they're able to actually 3D print a figure of her torso. So instead of just having a fuzzy little black and white picture, you're getting a real model of what your child is going to look like. People are using 3D printers to do all sorts of interesting things in terms of the environment. Researchers are using 3D printers that can print concrete to make replacements for parts of the Great Barrier Reef that have been damaged. Normally, those reefs take thousands of years to build. These scientists do is they find areas that are damaged, they make CAD replicas of those damaged areas, and they print them in concrete. So it's a base structure upon which coral can create a top layer, and that helps reintegrate the environment and helps return normality to that area. And one of the coolest things about 3D printing is that it's a community that never stops innovating. There are hundreds of innovators who are making little tweaks to these products, who are trying out different things, and so it really gives everybody an opportunity to create anything they can imagine.
So it's a pretty amazing thing. 3D printing food. There was a pizza 3D printer on CES in few weeks ago. So you can design a pizza and then you will have a printed pizza. Wouldn't that be nice? Body parts. There was actually a news that I saw recently about doctors that were 3D printed skull for a woman who had injuries, and they just printed the skull and placed it inside her head. Amazing stuff. For medicine, for doctors, this is really huge. Okay, digital transformation, the last topic. All of these industries, retail, banking, transport, they are getting transformed. And this guy, retail guys are going to go out of business, and e-commerce is going to become a place where everyone buys. We're in this pre-retail death, so things are really, really changing. And this guy says, retail is going away. It's going to change. And I did the research, and I know. And I will talk about this later. So we are changing businesses in new ways. They're optimized around real-time software. So software eats the world. That's the key. Machine learning, intelligent software. It has to be real-time. And then the last question of the day is this. What is going to happen to people's jobs? So this is the report that came out earlier this week. So impact being felt, everything is changing. In the next 2 years, we will see 3D printing, new technologies like Internet of Things, and then more advanced. So, and this is what the conclusion of the report was. Current trends could lead to a net employment impact of more than 5.1 million jobs lost to disruptive labor market changes in the next 5 years. So, and I could make a list of all the jobs that are going to be replaced. And it's going to be a really grim list. And I did this once when I was talking with people in government. And they were really interested. Really? Really? I don't believe this. Okay. But what are the jobs that get created? I mean, there are 2 billion, there are actually 7 million jobs that will be lost. 2 of them will be created. And that's the question that people have to answer. So I think we are getting out of time, but I've shown you a few technologies that are shaping the world today. So this is state today. We're sort of in a phase where a lot of enabling technologies will build something in the next few years. Really interesting. So I hope you get a few ideas for report. But I will be available here for a few minutes if you want to talk to me personally. Otherwise, we will continue on Monday. So have a nice weekend. Ja, koncept na plaats. Já, þetta er búin að skoða djúptek. Ertu búin að skoða djúptek? Þetta síðustu með á sína? Nei, þeir unnu